Hello and welcome, everyone. My name is Ryan Robinson. I am the Community Associate at Altimetrik Collider, and I'm accompanied by my colleague and Community Director, Jacob Smith. If you all are not already familiar, Altimetric is a digital transformation company, or in other words, we help companies stay ahead of the curve in technology and help source innovation amongst their teams. And tonight, we are excited to have Altimetric senior developers, Ankur Sharma, Ryan Moussa, and Yvan Gakuba take us on a deep dive into chaos engineering. So thank you for joining us and take it away, guys.
Hello, can you guys hear me?
Yes, we can.
Awesome. And y'all can't see my presentation, right?
Yes.
Awesome. Yeah. So yeah, my name is Yvan Gakuba and I am a software engineer at Altimetrics, and I'm here with Ankur and Ryan, my co-worker, working on the same project. And today we are going to be talking about chaos engineering, preparing for system for turbulence. Um, Anchor did give a little background of how all this came up. Yeah, I was during the Evil Week where we were asked to, break the system. And yeah, we were like, okay, how, like, we are not going to get all the time to always break the system by ourselves. And then we started, we found out about chaos engineering, and then we started reading about it. So, question, what is chaos engineering? So with microservices and distributed cloud architecture rising, the web has become increasingly complex. Therefore, failures are now much harder to predict. So a question remains: how much confidence do we have in the complex systems that we put into production? So that's the whole chaos engineering. So what you do is you are trying to break your system. You're trying to introduce chaos in your system in order to build more confidence, because when you have chaos, when problems arises, that's when you are looking for solutions and then you try to fix it. So that is chaos engineering. Then why would you break things on purpose, which is like the problem? Like, why would you want to break your system on purpose? We already have enough problems. Now you're trying to break something that you build. You do that because you want to identify failures before they become like outages in the system, right? Kind of like, we are in coronavirus time, and it would be better if, actually it's better because they found the vaccine, even though we don't have it, all of us, but it would be better to have it, introduce that little harm into our system for our body to get, acclimated to it. And then once you have it, you'll be able to, fight it. It's the same thing. So with chaos engineering, you're trying to introduce a little harm into your system, see if how your system reacts. If there's no issues, that's good. If there's issues, that's also good, because it gives you the opportunity to kind of like fix it. So what are the principles of chaos engineering? So the very first thing is build a hypothesis around steady state behavior. So what you're trying to do is you are trying to um, like build a hypothesis on the system, and then be like, okay, this is my like my steady system. That's how my system reacts when it's steady. And now the second thing is you want to now start introducing a little issues in your system, like slowly. You don't want to start by putting a lot of stress on your system. You want to start small, a little something, maybe say that you break your database, not you don't have access to it, or your services are not working correctly, like little something. You don't want to start big. um So it involves running thoughtful, planned experiments that teach us how our system behave in face of failure. Now, the second thing is very real world events. So you want to do stuff that are real world problems, right? When you're breaking your system, you want to do stuff that actually exist in the real world. Um, chaos variables reflect real world events. So consider hardware failures, you want to consider software failures like malformed responses, or even stuff like spike in the traffic or scaling events. You want also to vary all those real world events. Then the third thing is to automate experience to run it continuously. Like during that Evo week, we started like we were going to start. Some members of our team are going to be devils, and then some members were going to be angels, where like devils would break the system, and then angels would actually like fix the problem. But the problem was time. There's no way you would always find like a week or 2 weeks for all your team members to try to break the system, and then for others to fix it. So you have to find a way you could automate all that, so that you, if it's even possible, like have it in a pipeline, so that whenever you add a functionality or you add something new, you are able to like run the whole put chaos in the system, and then be able to see like how is it going to behave. Then the last thing is to minimize blast radius. You don't want to like do the whole, you don't want to inject all the errors of the world at the same time. You want to like minimize it, because one of the chaos like a chaos engineer is responsible to ensure that the fallout from the experiments are minimized and contained, because you don't want to break the whole thing. Okay, so it's in that perspective that when we talk about like automate experiments to run continuously, we started looking for something that would help us, kind of automate it. And we started reading about the Chaos Monkey for Spring Boot, because all our environment is made up of microservices that are built using Spring Boot. And then we started reading about Chaos Monkey, and Chaos Monkey was designed by Netflix to test system stability by enforcing failures via pseudo random termination of instances or services, right? Um, and then it consists of two things, which are watchers and assaults. Watchers are Spring Boot, our Chaos Spring Boot components. What they do is they scan your whole application, looking for specific annotations, which are at rest controller, at rest service, at repository. That's what the watcher is looking for. Now, assaults are the scenarios you want to test. The way it works is what you do is you configure assaults, the scenarios you want to test. It could be either latency, or it could be exception you want to throw, or you would want to definitely kill your app. So you do configurations. So now what the watchers will do is they actually use the AOP concept. So they look for public methods, and then once those public methods are ran, so what it would do is it would introduce like you would throw exceptions, you would add latency in the responses that methods are when they're running, or like we just said, kill the whole app. So here we have the kind of like the structure. So the watcher, like we just said, it's gonna scan for the controllers, repositories, services, REST controller, and all the components using these annotations that are specified. Now, each watcher, like the watchers now uses these assaults that we just defined here, the latency assault, add random or configured latency on the watcher, and then the exception assault randomly throws runtime exceptions when function on the watcher is a function on the watcher is triggered. A kill app is will be will arise when a kill app assault will arise when an object on the watcher is also like triggered. So let's take a small example. Like let's imagine that we have this little these microservices, two microservices that are connected to our discovery service, and there's a gateway service in front of them. Now the first part here, it shows it without Chaos Monkey library added to it. The second part is when we now introduce Chaos Monkey. So whenever you call a service within these microservices, the Chaos Monkey will decide if it feels like injecting like a latency assault, that's what it's gonna do. If it decides to inject like an exception assault, that's what it's gonna do. Or it might decide to kill the whole app and the app won't be available. So that happens whenever you call one service, whenever a service calls another service. Yeah, so that is that. Now, I'll switch over to a demo. So we have a config server running that is that is pulling all our configuration server, our configs from a repository that I have on GitHub. And then we have a Eureka server here, and then two services, a song service and an artist service. Now, the very first thing you want to do is you want to add the Chaos Monkey library. I use Gradle, so we use Gradle. So we have the Chaos Monkey library added here. And then once you have that added, the second thing you want to do is you can enable it using a profile. So this profile, which is Chaos Monkey profile, and then you want to add actually in both your services, right? So you'll see that I've added in both my services. Then this will bring in we'll bring in the Chaos Monkey, so you'll have all your watchers in your system already. So the thing that is remaining that you have to do is you have to actually now configure the assaults. So that is central configurations. So you'll see that I have enabled I've enabled my watchers on all my controllers, repository, REST controller, and services. So that means either one of my controller, repo, or service can be broken. Now, what do I want assaults? So I've said, okay, every two calls that come to my microservice, break it. I've also added latency. So these are the latency assaults in a range of 5,000 to 10,000. Then you'll see that I've activated the latency, it's active. But right now I've decided to say, okay, all the exceptions, latency, please make it false. Same thing as the kill application. I've also disabled it right now, it's false. So, so what I want to do now is go back to this. And now, one thing that we did actually is because we had already build performance. We had performance a performance environment. So we already had like performance tests already made. So for that, I was using my I've already drawn a few of them. So what I want to do is I want to clear all this stuff up. Yeah. Now, let's kickstart this by making sure that we disable the chaos monkey first and then run it without any chaos introduced into our system. So I will do this. No chaos monkey. So what we're going to do is we're going to first run it without any chaos monkey in it. And then we will see that all the calls that will be made will pass, no errors. So it's going to be, 100% success. And then later on, we will bring in chaos, and then we'll see how it goes. So yeah, now I have my Geometer here. I'll run it and go here, summary. Yep. So I need to pull this thing back up. Yeah. So as we'll see here, there's no errors. So we called everything and there's no errors because our chaos monkey was disabled, right? If you want to see the like individual stuff, so we'll see that everything went well and there's no issue, right? Now, this is what you want to do first. You want to run in your environment without any chaos monkey and see if every single every single call that you're passing passes, like every single call that you're making passes without any issue. Now, once you're done with that, what you want to do is you want now to enable your chaos monkey. Let's say, for instance, also you want to bring in the exception. So we want to have this one true. Now run this one. So cool. Now I'll go back here to my Geometer and I'm going to clean everything. Then I will send it. So it's gonna take, actually I should have, because I have this latency that I added, it's now taking time. Probably should have disabled it so that we first see the exception once, and then later on active the latency assaults. Yep, but now you'll see that we started having errors that are being thrown here. Now, if you, for instance, come here to this one, all the saves are okay, but this one, if you check on the response like this one is decided it to make it, this one is not available. This one is 500, but this one passed and we have a 200. So that's how it kind of like works. It decides which one is going to pass, which one is going to kill, and then you actually have to go through all the requests and see like what chaos is being injected into your microservices. Let's see, for instance, like this one, response data. So you'll see, like for instance here, you'll see that we're getting an internal server error. And then here it's saying, hey, it's a Chaos Monkey runtime exception that was thrown by the Chaos Monkey that we added, right? So all these are the observations that you do when you are introducing Chaos Monkey into your system. So it's doing all these things because it's running most of it because I've decided to have a loop count of 10. And then every time, because I'm using, it's one thread, one user, but I have 10 loops. So it keeps doing, keep looping, sending requests. It has to do that 10 times. So that's why all this is happening. But you can get to see all the tree results here. And then if you want, you can like analyze what errors are being, thrown into your system. So that's that. Go back here, and then if you want, you can also go here, try to analyze the logs that you are getting. Yeah, like I've showed you, we can get to see that these exceptions are being introduced by the Chaos Monkey. So yeah, that's this. Now, this was good enough for us, but we thought, okay, how can we verify that all these errors are also we are also being notified whenever something is crashed in our system, because it's important to know that, okay, this service is not available. So what we had done, go back to my presentation a little bit. Okay. Yeah. So what we did is since we had our performance environment and then we had all these tests already put together, what we did is we created a job using Jenkins that ran all those performance tests in a testing environment. What's gonna happen, and then we had to run it twice, first like we just did without Chaos Monkey, and then the second time with Chaos Monkey. So with Chaos, so since all the logs are being collected by PCF, and then we have a syslog that drains all the logs that we need to Splunk, and then we can draw dashboards. So with the dashboard, you want to see if, let's say for instance, with your Geometer and all your tests that you're running, you had, switch back to Geometer, yeah, here. So let's say you had 10 threads, right? And then you have 10 or 100 loop counts. So you already know how many requests you are going to fire on a given endpoint, right? And then what you want to do is you want to go to your dashboard, Splunk dashboard, for instance, and then see the 200, the number of 200 you're getting, and the number of 500 you're getting, plus the number of 404 you're getting, all that counts, the summation needs to be equal to the number of requests you have fired. So now you know that, okay, your Splunk dashboard is actually reflecting what happened. Same thing is like, since our Splunk has hooks to Slack, and whenever there's errors, they are sent to our Slack. We have Slack groups, so it's going to be sent to our Slack, and then you can go there and then verify and be like, okay, I had maybe 200 errors that were generated. Did I have 200 notifications? I had, let's say, maybe 100 not found responses. Did I have 200 not found notifications? Depending on on which level you decided, you receive notifications of. Now, same thing happens with Victor apps, where we are like, okay, all the issues that are generated, Victor apps will help us, do a follow-up. So you want to see if all those errors that were generated on the Victor apps side, if you did receive. So all these three tools, they need to have the same number of errors and errors as the one you actually have in your that you have in your Geometer, and you have the same numbers in Splunk, same number of notifications, depending on which ones you decided they were going to notify you. So all that will give you a whole picture of how your system is actually behaving. So yeah, that's what I had for the team today. And I think now we can have a conversation, questions, maybe suggestions from any of you who might have suggestions, or Ankur can forward me if I forgot, can back me if there's something that I forgot to talk about. Yeah, let's make it.
Anybody have any questions?
Ichan here. Thank you for the presentation. I'm curious if your, I guess, logs don't match up in one place or another, how would you go about kind of troubleshooting to see what the actual underlying error might be?
Yeah, I can answer that one, Kitchen. So that actually did happen. What we did is we had a load test where, and we are a product of some 12 microservices, and each microservice is having some 6 to 7 endpoints. And we did a load test. And initially what we did is we turned chaos on, and our assault level was 15, which means that every 1 out of 15 call will fail. And we run the load test for like 30 minutes. So that means in those 30 minutes, we executed 10,000 calls. So what happened was 1 out of, every 15th call was failing. So we kind of generated somewhere around 4,000 or 5,000 errors. And that actually, luckily our Splunk infrastructure was great, and all the errors did travel in the form of logs from PCF to Splunk. But Splunk Alert, they have a webhook in the backend for the infrastructure that we have at the company, right? So they were talking to Slack, which is a Slack message, right? And they're also talking to Victor Ops, which is an incident reporting system. They got overloaded. Those webhook channels cannot accept more than 100 errors or incidents within a second. And Splunk was sending them thousands of logs or incidents. So we actually talked to infra team, and they said, this is what the infra limit is. So if your system is sending more than 100 errors, your system is anyway too bad to follow up. So, forget about the rest of the 900 errors. So then after that, we kind of did a controlled amount of testing. We reduced from, doing that much of chaos where 10,000 events can generate thousands of errors. We kind of reduced our load from our basic load test, and run the chaos engineering for 15 minutes so that we can generate somewhere around 100 errors. But the fun thing about chaos is all those 100 errors are occurring at a very different point of the system. So that's what we want. We want variance, right? Because we have so many watchers within so many microservices, and then chaos pick a different watcher every time, and then it creates a different assault. So that variance is what we were trying to look at. If there is any unknown exception or unhandled system error that happens, we are able to capture it. So that's what we were able to prove.
Great. Thank you.
Anyone else?
So Ankur, one question I have is, you gave the example of Netflix trying to break their own system to simulate malicious users. Using that same kind of behavior, are there any examples where you would say the chaos engineering testing infrastructure is not a good fit for the product or process that you're testing, either by not necessarily generating useful data or not necessarily being a good use of resources, that's possibly as well.
Right. For our system, we are actually not consumer facing. We are actually getting used by the FootPass app. So we are kind of an internal service of all that charging ecosystem that we manage. So for our system, it was perfect. All we have to do is just tweak around bad system calls, which Chaos was doing for us automatically. So we never have to go into creating bad users or, create a bad user experience strategy. But yes, if there are teams which are managing like apps on iOS or native apps on Android, they can definitely explore in that direction. We actually didn't got a chance to explore in that direction.
Got it. So there's a strong aspect of, how consumers might use it versus internal systems.
Right.
Okay.
Yep. It's evolving. Netflix again is strongly using it in their Spring Boot microservices, same as us. So that piece we have covered. But if we are building native apps in the future, definitely would like to utilize something like this to create chaos, create bad users. What Netflix is doing for that, it's not public in nature right now. They are doing it, that's public, but there is no tool publicly available to replicate that behavior. But we'll see. Hopefully we can create one.
You guys are ahead of the curve as always. Nice job, both of you.
Have you ever experienced those rage rooms where you get to break things? So it's a new stress buster thing. And you go into many of those escape rooms now they have rage rooms. You can go and break stuff, and it kind of relieves your stress. So similar thing, we kind of had an evil week where we were given an opportunity to break the system, like break it in all possible manners. And we did all that, but then we realized it was very stressful, right? Because instead of, we can't do it again and again. How often can you find one whole week where whole team can just align and start breaking stuff? So we thought we need to automate this chaos. And that's where, we learned about chaos engineering and started working on that. So pretty much now we have automated it and we can create chaos anytime.
With that being said, I would say it's safe to say that this concludes tonight's discussion on chaos engineering with Ankur, Ryan, and Yvan. So again, thank you, gentlemen, so much for sharing such awesome expertise. You all are like really just the epitome of how our company stays ahead of the curve. We will be posting this video on our YouTube channel, and we strongly encourage everyone to follow us, connect with us, tune in for more events in the future. And just please come back. Jacob and I and the Collider team, Abby, thank you. And have a great night, everyone.